Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to talk about how to get your PCB data out of Fusion and upload it to PCBWay. Now, while this might seem like a pretty simple and straightforward process, having been through it a couple times, there are a couple of tips that I want to give you to make sure that your designs come through and get delivered as expected. So keep in mind that we have done PCB content before. We recently talked about this product, which is a nightlight coaster that I've been using for weeks now, and I absolutely love it. We've also done a series on our learneverythingaboutdesign.com website where we talked about designing and building an HID game controller. We walk through the entire process of picking components and breadboarding and programming, and finally designing the PCB, building it, and building a housing both for 3D printing and injection molding. So if you want to check any of that stuff out, I'll put links in the description. But for this video, we're going to focus on getting this data out of Fusion and upload it to PCBWay. So the first thing to understand when we're talking about PCBs is there is some metadata that's associated with it. When you develop your own circuit board, you start by creating the schematic. This is essentially the blueprint of what you're going to do. And when you think about a schematic, what we're really talking about is all of the different interconnected pieces, the power and ground, the resistors, the capacitors, and all the separate components that you need to make your design work. Doing this at the schematic stage is going to give you all the information that lets you transfer and move over to the actual PCB layout itself. Keep in mind that all of the data associated with these components happens at the sort of the library symbol level. So each component will have things like silkscreen that's going to show up on the physical PCB, information like the resistor number or capacitor number, and information about the component itself. This is important because as we begin to take these designs out of Fusion and take them to PCBWay, we want to make sure we identify and understand things like the bill of materials, a list of components that we need. So as we transition from our schematic and over to our PCB layout, the PCB layout is where we're going to define everything that gets physically made. This is going to be where our pads are going to be located on the physical circuit board, holes for hardware, any additional silk screens or logos, like here you can see we've got the lead logo here. So all this information happens at the PCB layout. The reason this is important is because this is most commonly where mistakes are going to be made. We've got tools like quick routes and auto routing that we can use, but that doesn't mean that the board is perfect, and you need to be able to walk through and check it. So in this case, what we're going to do is we're going to talk through a couple of different steps in the process to make sure that we understand the things that we should be checking. First, we're going to be talking specifically about what's called a two-layer board, which means top and bottom. There are going to be multi-layer boards, but we're going to not focus on that. And I would assume if you're doing multi-layer boards, you're probably not even watching this video. So the first thing that I would check here is I've got a ground plane or a polygon port on the top, which is connected to my 5-volt pin on my Arduino, my QT Py board. So you can see here that there are some little red tabs that are going between the 5-volt pin and the top. Now, if I'm to look at the bottom of the board, you'll notice that we've got these sort of connector pieces going between the ground pin. And that's because the bottom polygon pore, the big blue area that we see, is the ground plane. That's how I designed the board. And the top is going to be a power plane. Generally, what we do when we're designing these things is we try to simplify the number of connections needed. Now, having the power and ground plane on the top and bottom didn't necessarily make this very easy because all of my components, or the majority of them, are surface mount, which means that I would need to run vias or small holes through the board to connect the top to the bottom. So you can see here everywhere there's a ground connection, there's a small green dot, which is a via. This is an area of copper that is connecting the top layer and the bottom layer. So when you take a look closely at your boards, you want to make sure that things like the ground pad is isolated from the polygon pore on the top. If that's not true, then you're going to end up getting power and ground connected directly. Now you can see on the 5-volt pins, or the 5-volt pads in this case, that those are connected directly to the top level of the board, which means that everything that's 5 volts should be connected directly, and everything that's grounded should be isolated by having this blue border, which allows us to see the copper on the bottom. This board by itself is not particularly tricky or complex, but even with a board like this, you really need to make sure that you spend the time and go around and check everything. There are some simulation tools in Fusion where you can use SPICE data and you can simulate your circuits. But in most cases, if you're building a simple circuit like this where you're using an external microcontroller, doing simulation is going to be something that's very difficult. So we're going to focus on manually checking everything. Once I'm happy and I've gone through and I've manually checked everything to make sure that my power and grounds are all okay, I've got all my vias connected, then I would go and I would do an error check. So there's a tab that's automatically displayed here on the left-hand side, and you can see that we've currently got no errors. An error would be if you've got what's called an air wire disconnected, if you're breaking some rule like one of these traces is going to be too close, the route's going to be too close to the edge of the board. So if I select and I delete this, for example, now we've got one issue because there's an unrouted air wire. Now this means that my circuit is not completely connected. I'm going to do Control-Z to undo and put that back, but these are examples of errors. Now, by default, you've got error checking that happens constantly. It happens all the time, but this is actually a setting that you can turn on. So under the rules section, there are some preferences that we can manipulate for designs, some of the issues that we can change, whether or not we're following design rules and we're manipulating these clearances. If you leave everything as default, then this should automatically be turned on and you don't need to worry about it. However, if you do turn it off, then you would want to make sure that you go through the process of doing the design rule check. So basically, you would go and you would click this button, and it would run through, and it would validate whether or not there are errors. I'm going to go ahead and delete one of these again so we can run through it. And then it would just display here. Basically, it would tell me that I've got this unrouted section. So that is going to be the next step in the process. So manually look through and validate everything. Secondarily, you want to go through and do your design rule check. This used to be called the DRC, and they've updated it since September, so it looks a little different now. But essentially what you do is you've got all these different preferences in here. The layer stack option, again, has some basic settings in here, information about how thick your traces are, whether or not you've got a specified clearance around certain parts, information about how big the solder masks need to be, and any of these things will trigger an error if you violate those rules. So again, if you leave everything as default when you start creating your own circuit board, all of this stuff will be on by default. But if you start manipulating those, you'll start to see some of those errors pop up. So always double check that. Make sure before you ever send any design data off that you validated it. The next step in the process is to go to your manufacturing tools and start to generate the manufacturing files. Now, there's actually a couple steps here. Depending on your workflow, it can be as simple as just clicking either the ODB export or the Gerber export. I personally like to first go into CAM Preview. The CAM Preview is going to allow me to see a preview of the board. What I look for here is, again, I want to make sure if I zoom in, that I see, for example, I've got copper connected for my 5 volt on the top. If I look at the bottom side of the board and flip it over, I should see that my ground is connected on the bottom. And that's going to be important to make sure, again, that my power and ground are okay. I also want to double check things like what's going to display on the silk screen. So you can see here for my switches, I've named them switch off and switch color. So this is a good indicator on what those do, but it also left the part number here. Now, if I don't want that displayed, then I would need to go back in and make sure that the text is not displaying on the silk screen layer. So all that is easy enough to do, but these are things that we want to double check. So for example, the resistors, we've got R1 and R2 in this version of the board. It doesn't display the resistor value. That's something that we would look up in the bill of materials or parts list, and then we would be able to understand where R1 goes, where R2 goes. So again, looking at this basic information, make sure visually it looks right. Make sure that the holes in the board are actually holes. Make sure that the vias are drilled through for all of your through-hole components, and make sure the top and the bottom look okay. So this is sort of a visual check. There's also information about the drill hole sizes, and you can get basic information about the board itself. So for example, you can see that it's about 89 millimeter diameter. That's going to be important when we go to upload it to PCBWay. So in that preview document or dialog, let's go ahead and bring that up. There's also a CAM button here. Now, if we click that, what this is going to do is it's going to open up the CAM processor. The CAM processor is just the next button in this list of tools here. So you can either do it from that preview window or you can manually go into it. So the second reason that I like to use the CAM processor as opposed to just doing the ODB or Gerber export is because I can drill down into each of these file types and make sure that the output is what I'm expecting. So for example, when I look at the top copper for the Gerber, again, I'm checking to make sure that my 5-volt pad is connected to that copper layer. Now you may notice on these that the copper doesn't have any of the through holes, the vias or the through hole components. And that's because the way the boards are built is the copper layer is there, and then the area that is removed, the white area, is machined away, and the holes for the vias and the through hole components are drilled. So through that process, we want to make sure that we validate the copper layers on both the top and the bottom. Again, making sure to check the ground pin is connected to my ground plane. I then want to do things like double check the profile. And the main reason for this is because oftentimes when you're generating the shape of your PCB inside of Fusion, if you're not doing it as a sketch in the design workspace, you may find that the way you create these circles aren't actually defined as holes through the board. Now, I've had this happen to me before where I had a hole that restricted the polygon pore, the copper on the top plane, but I didn't actually have a hole go all the way through the board. So for me personally, I create all my board shapes as sketches in Fusion, and I use those as opposed to just generating them inside of the PCB layout. I find it's much easier, but definitely check the profile to make sure that all the holes are actually there. And then you can double check things like your solder mask for the top and the bottom and solder paste, especially if you're manually soldering these things. You want to make sure that those are right. And then again, check your silk screen. Make sure that any logos are there. Make sure any information about where the components are located, capacitors, resistors, and all that data should be there. Next, you can go into things like the drill. And basically what you're looking at here is making sure that you know exactly where and what file type is being created for the drills. This is important because this is how, when the PCB is created, this is how they know where to put those vias, how they know where to put holes for through components, and also to create the holes for the hardware. The bill of materials, basically what we're going to do here is determine what format that we want. So for example, a text file as opposed to a CSV. And then there's a pick and place document that gets created as well. I like to do these export as zip, and then I can process the job. Then I need to pick where this is going to go. This is going to be saved locally, and all I'm going to do is I'm going to save this just in my downloads folder, and we'll go back and we'll just pull it from there. Once we process the job, I can open the folder. It's going to show up on another screen. I'm then going to say cancel and discard this because I also want to talk quickly about the export Gerber. So what happens when you click this is you don't get any of the manufacturing preview options that we saw in the previous dialog, but it's just going to generate all of the information we need for a Gerber file. So it's going to have all the different Gerber files for things like the top and bottom copper, the profile of the board, the solder mask and solder paste, and so on. It has the drill file. It has a layout for the text. So basically these are, this is going to be the bill of materials, and this is going to be the information for a pick and place machine. So if you generate this, basically if you generate the Gerber file, I'm going to put it in the same location, and I'm just going to say GBR only for Gerber only. Essentially what's happening, and if I bring this over, you can see it in my downloads folder here. Essentially what's happening is, let's go ahead and just clean this up. We are getting zip files. So the Gerber only, if we go into it, it's going to show the work hub that I'm working in, the project where this is located, and then it's going to have a CAM outputs folder. So there are Gerber files, there is going to be drill files, which again is that XLN, and there's going to be an assembly section. This is information text documents for pick and place. There are no surface mounted components on the back or the bottom of the board, so this is empty. There are going to be components on the top. Things like the LEDs, the resistors, the capacitors, those are all going to be in that text file. And then there's a text document here for the actual bill of materials, the parts list. Now, if we go back out and we take a look at the one that came from our CAM, the sort of first dialog that we looked at, the CAM processor. So we have the same Caducation work hub, But we also have this CAM outputs folder. Now the CAM outputs folder is basically the ODB file. So the ODB version of what a manufacturer would need. So if we go into each of these folders, we're going to get all of the different information that a manufacturer would require if they want an ODB file. And the only difference between these two, again, is the fact that the Gerber only generates only the files required for Gerber manufacture, while the original one we did contains both ODB and Gerber by default. So I'm going to only look at the Gerber only, and I'm going to right click and I'm going to extract this here. And the main reason for this is because we want access to some of this data. I'm going to go down and just drill down into the folders. And the Gerber data is the first thing that we want to take a look at. I'm going to pull this off screen and I'm going to go to the PCBWay website. So on the PCBWay website, while this step isn't required, I think it's incredibly important that you do it. So I would go to their online Gerber viewer. And then what we're going to do is we're going to take all of these Gerber files and we're just going to drag and drop them here. And the main reason that we want to do this is because I found that there is sometimes a slight difference between what we see in the Fusion Gerber viewer or the preview and what we actually get when we upload it here. The first set of boards that I had PCBWay make, I had a power and ground plane on the top. And in Fusion, I had to trick the software to make this work. It didn't really want to have two separate polygon pores on top, but it previewed just fine in Fusion. However, I didn't catch that it didn't preview fine in this Gerber viewer, and I ended up having them make some boards that are just unfortunately not usable. One thing that you should know here is that this Gerber preview doesn't contain information about the drill holes. So you'll notice there are no through holes for our QT board or any of the surface or the through hole components or any of the vias. All of those are still solid. And that's because we only sort of uploaded the Gerber files themselves. It doesn't contain information about the drill holes. But what we should be sort of checking here is to make sure that the top and the bottom of the board are correct. Make sure that your silk screens are correct. Make sure that all the layers are correct. So you can go into this layer view and you can toggle on and off different layers. So if we don't want to see any of the bottom stuff or even the outline, we can focus solely on the copper on the top and make sure that when we're looking at this, that again, 5 volts is connected. And if we do the same thing for the copper on the bottom, we want to make sure that the 5 volts or the ground is connected here as well. The zoom in and zoom out I found is a little kind of finicky on the site here. It does not like to zoom in with the mouse wheel. It wants to scroll up and down, but you can kind of play around with it and get used to it. There is also a 3D viewer. You can use that if you want to try it, but for the most part, again, just checking the top and bottom layers and making sure that the silk screen, make sure all the components are coming through. That's going to be that first step. The second step in this process is to create an account, which is free, and then start with an instant quote. Now, the process requires you to do some basic information first before you actually upload files, and it'll give you an idea on the price without ever having to upload your files. So you can kind of get an idea if you're doing, let's say, a standard PCB, or you're trying to do a flexible PCB, or maybe use an advanced one, something that's made out of aluminum. So you can just play around with these numbers. So the first thing that I'm going to do is I'm going to do a single piece. We're going to do one design. We don't have multiples. And then we need to do length and width, even if it's a round board. It's going to be 89 millimeters by 89 millimeters, and we'll do 5 pieces. It's a 2-layer board. Again, that's top and bottom. And I'm going to use all the default settings, the default material, the default information about thickness. And the only thing I'm going to change is going to be the solder mask on top. I'm going to make it red instead of green. And then everything else I'll say no to or go with the defaults. There are no edge connectors. Don't have to worry about doing plugging vias, and everything else is okay. If you want to use their assembly service, you can click and add the assembly service here, and you will need to provide a bill of materials and information about each part you want. I would say that going through that process is still relatively simple because we have all the information, but you will need to download the PCBWay. They have a sort of default Excel template that you want to use, and you just need to give them information about the part, the number that you're using, the manufacturer, and then they'll come back and say, okay, we can or cannot get this exact part. Here's a replacement. Will this work? So once you filled everything out, we'll hit calculate. and it'll give you a price. So you can see here the PCB cost, basically $1 a board and $20 to ship. We're going to save that to cart. Again, you'll have to go through some menus. In this case, make sure that it is not part of some sort of control regulation. It's not a military component and so on. We agree. And then it comes into the section where we can upload our file. So you can see here that we want to use the Gerber files. This can be a .zip file. So what we'll need to do is we'll go back to our Gerber files folder. And basically what we're going to do is we're going to take that entire zip file. So I'm going to go back to the top level, and the zip file that was just the Gerber only, I'm going to have to expand this here. The one that was just Gerber only, I'm just going to drag that entire thing over, and then we can submit order from here. I'm going to cancel this because I'm not going to order this board again, but that's the entire process. Now, after you upload it and you submit those, then they'll go through and review, and they'll contact you if there are any problems. If you are using the assembly service, remember that the first download that we have, if we go into these zip files, that we do have information about the assembly, the pick and place, and the bill of materials. You will need to create a bill of materials in their own format, which again is pretty easy. You just need to transfer what you have here in a text document to the Excel file that they use. And you will also need to point them to the location of the assembly documents for the pick and place machine, or upload those individually as well. So I would suggest uploading these individually if you're using the assembly, and then just include them in the bulk zip file as well. Now I'm going to go ahead and delete this because I'm not going to use it. And I'm just going to say other reasons. And I want to take a look at the orders, the original orders that I placed. So again, I ordered this board a few times. The bare boards, just like it said in that quote, because it's the same file I used, is $25. So $5 for the boards, $20 for shipping. The assembly service to populate these, which included the price of the RGB LEDs, it included all the capacitors, the resistors, and all of through-hole components I left empty. So it didn't include a microcontroller, the push buttons, or the FSR in this case. All of those were empty, but everything else was populated and built. So for 5 boards, it was about $180. Now, if you look at the price for just the LEDs, for example, basically it's a pretty good deal. Now, I built a couple of these boards and I ordered the LEDs and all the components myself. I spent probably around $100, not including the microcontroller, not including the through-hole components that I was going to need anyways, but about $100 is what I spent to get enough components for all the surface-mounted stuff to basically build this. So I spent about $125, including the boards and parts, and then still had to manually solder everything myself. So keep that in mind, that it really only cost about, I'd say around about $50 to have 5 of these boards assembled, which I think is a pretty good deal. If you've ever soldered surface mounted components before, especially a bunch of these little capacitors and LEDs, you'll know that it's a pain in the butt and it takes a good bit of time. So if you're prototyping a board and you're not sure if it's going to work, I would suggest going with bare boards and then assembling them yourself. You have a bit more control and you're not wasting a bunch of parts if it's not going to work. And if you are 100% confident in your board and your design, then having the assembly service done for you can save you quite a bit of time, effort, and headache. So hopefully this video helps. I know it's not that difficult of a process, but there are a few of these steps along the way that I did find needed a little bit more explanation. So if you have any questions on this, then please let me know. Remember that we did an affiliate sponsored video for PCBWay. You can check that video out. This video right here is not sponsored, but I did enjoy working with PCBWay, and I will be using them for all my PCB designs from here on out. So I did want to make sure I at least covered how to get the data from Fusion in there. If you want to see more content on PCB design or PCB work, please let me know in the comments. I know I've got a couple of comments about that. It does take a good bit of time, but it is pretty rewarding to be able to make your own designs. And with that, if you have any other questions, please let me know. As always, thanks for watching, and we'll see you in the next one.